was good, Joe. Day 221. I think the mic is a little bit better now. Okay, I don't know what's going on. I removed the other one. I don't know what this mic. This is a new thing, probably, because this is something that I've never messed with. So, but I thought you would have to input a source, but it seems like it captures audio too, and it sounds a little better. If it doesn't, then sorry. So, yeah, let's get through this lesson here. What is TCP versus
What is a protocol? To put it simply, a protocol is simply a design or a spec for one computer or device to communicate to another. It describes how you break down the data, how exactly it is formulated, the header packets and all that, so that the other side can reconstruct messages sent across the wire. So why does HTTP1 use TCP? Well, TCP is reliable in order packets. Let's do a little example here. Let's say I needed to send it off something that contained 8 packets in it from one computer to another. Now, how this would normally be done with TCP is I would have something called a sliding window that will contain how many packets we can have out in flight at one time. Let's pretend we had a sliding window of 4. That means I can send out packets 1 through 4 to the destination computer. So 1 would go across. When 1 gets over, the receiver needs to send an acknowledgement. The acknowledgement will come back at some point, and when received, our sliding window can proceed and send this out. While we're waiting for that one acknowledgement, we can send the other packets out that are within our sliding window. This allows us to send a bunch of data at once, not just sending one simple packet at a time. This is how TCP is in order and reliable. Every packet that is broke down for a big piece of data is broken down to individual packets with IDs, shall we say, and a destination, which port it needs to go to, and then it will properly be routed to its address, and the receiver will be able to reconstruct the data in order. And obviously packet ordering makes perfect sense why it's important. If you were to send, say, a JSON object across the wire, remember, that's just text, right? That's just simply bytes. We can send that across the wire. But what happened if you got it out of order? Well, you wouldn't be able to use JSON parse. It would explode. You would get an exception in JavaScript. Now, you've probably heard of something called UDP, which is a little bit different than TCP. But generally speaking, UDP is considered more performant because it does not wait for an ACK. But here's the deal about UDP. With TCP, you send across your entire JSON blob. But with UDP, you have to make the decision how you're going to break up all of your data, how you're going to organize it, how to reconstruct it on the receiving end, and then how does the receiving end know that it's missing a packet? And so this is very, very important. So let's just pretend this again. We're gonna send all 8 pieces of data at once, just bam, 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 bam. We have to come up with a strategy to know if the receiver hasn't received a data. Maybe it didn't receive packet 6, so the receiver is gonna send a NAK, a negative acknowledgement, and say, hey, you know what? I didn't get this one. I seem to get everything else, but I didn't get that one. Now, it still may be in flight. It still may come. So you'll have to come up with an algorithm that can receive 2 of the same packets. You're going to have a lot more protection in it that you don't even have to consider when using TCP. But you can see why this is more performant. There is no acknowledgements. And right now, a pretty good packet loss rate is less than 1%. So let's pretend for a second that it is 1%. That means you're only losing 1 packet out of 100. That means you are not waiting for acknowledgements 99% of the time. And that one time it does happen, you do end up getting a NAK, which means you have to be able to hold the data on your server long enough to be able to negatively fulfill requests that you've sent with UDP.
Okay, user datagram protocol is compared to TCP as they are both transport layer protocols. Here are high-level differences between the two. So, there's a connection, yes. For TCP, no. TCP, yes. UDP, no. Handshake, no. In order, no. Blazingly fast, yes. TCP establishes a connection between the sender and a receiver with a handshake and ensures that all data is sent in order. UDP yeets the data to the receiver and hopes they can make sense of it. There are a lot of good TCP. Okay, what the? Okay, bro. Alright, move your main.go into a. Okay. We're gonna have a few different programs in this course, so we need to keep things organized. Alright, let's start with that. So make 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 their let's see CMD TCP listen TCP listen. Wait, how do I? There's got to be a way to make nested. Wait, how do I do that again? Make nested folders like. Always gonna. I forgot how to do that. Oh, dash B. Dumbass. Wait, let me try that again. It's a matter. Remove. I guess we do. Remove dir cmd. We'll do this. So make dir dash p and then cmd slash tsp listen. Beautiful. Okay. Wait. Move your into a. Wait, is that a file or folder? Move main.go to cmd tcp. Okay. And then go run cmd, right? cmd. Okay. Separate terminal connect to this. Okay, okay. TC or NC and network connect dash V local localhost 420.69 succeeded, and then I should see accepted connection. Wow. All right. Kill both programs with Control C. Did that. Did that. Did that. Okay. Okay. Run NC again, but this time with the server terminal off. Okay. Oh no, it failed. That's because default can be established before data can be sent. UDP has no such requirement. Run your program again, redirect the output to that. Okay. And then we will submit. Nice. All right. Nice little conceptual lesson. Whoa, what's going on here? All right. So we've seen this TCP sender requires a connection to be established before the data is sent. Let's build our UDP. See how it differs. Create a new program that eats UDP packets at a server. We want to fully understand the difference between TCP and UDP. Okay. Let's do this. Is it wait wrong? Is it in this command? Up sender. UDP sender. UDP sender. UD UDP. Go. Package. Main. Main. That can be okay. Create a new main.go in that can be run with. Okay, yes. The program should start using net.resolve UDP. Okay, so first let me make func main. Right? Use okay. Let me just see how this works. Should be so much. Yes, should be the same, right? Resolve UDP address to resolve the address. to resolve the address. So what does it return? A UDP address and error. Okay. So let's do this. So UDP error. Let's also import that. Import net, I guess. Net dot resolve. I know. Resolve net dot resolve UDP address. And we'll do something and something. What does it take? Network. Well, we want UDP, right? And and then the address source. Localhost. Where are you? Localhost 420. So I think it's just 420 like this. 42069. Same pattern, I believe. Okay, if error, let's also import log. Failed to resolve. Okay. Now use this. I don't know what this does. Okay. DAO UDP network. DAO UDP acts like a DAO for UDP networks. The network must be a UDP network. Still don't know what this does. To prepare a UDP connection and defer the closing of the connection. Use net.dao to prepare a UDP connection and defer the closing connection. Standard in. So so use net.dao to prepare the UDP connection and defer the closing connection. What is net.dao? Oh, that's how you get the connection. Okay. So con error udp.con or what is it called? Dial. Oh. Oh. What? So it doesn't have these methods. So what do I put? Network. UDP. Um, LH. I have no idea what this is. dot you to prepare. Okay, hold on. Maybe okay, I'm wrong. Net dot down. Yeah. I don't know. Okay. What is it? Okay, DAO acts like a for UDP net. L is nil. L. Oh, local address. Okay. So we could do 42069. Okay. Remote address. If the IP field of okay, I'm just gonna put nil. I don't know what to put in that. Oh, what are you supposed to put? Local address is automatically chosen. If the field of the remote address, or I don't know what our address means. La la la. Man, what am I supposed to put here? Okay, so I need to put some kind of reference to something. So maybe the UDP here. Ooh, it doesn't cry. Okay. If okay, now I have a connection going on. I guess defer. I guess defer dot defer con dot close for create a new buffer. Okay, I need to read about these because I forgot how to use this. Okay, reader. Create a new buff file. Okay, I need to import that as well. Buff file. Um, so buff. Okay, buff file dot new reader. Okay, what is it? Oh yeah, new reader. New read. Okay, there you go. So new reader returns a read object. Buff. I need to pass anything, right? Oh, I do need to read passing something. No, something that. Okay, so maybe the connection, right? That reads from OS. That's the okay. Ba, ba, what does this do again? Read from student. Go. This is a complication. Okay, yeah. So it's reader buff file dot new reader os dot stit in. Right. Okay, they call it a scanner. what is they want me to do? I'll say reader. Reader makes more sense to me. I have a reader, and then for scanner.scan. Okay, so now I have an infinite while loop. So we'll do for true fmt dot print. Oh my god, I gotta freaking log that too. fmt. Um, we'll do this. And then scanner.scan. Read lines from buffer.reader using reader.readString. Okay, so reader.read reads into the first occurrence of the lim in the input. Okay. It's text. Text. If oh my god. Log dot fatal. Fatal. Okay, so then con that right. Okay. Con dot right. Text. Wait, what does that take? Bytes. Okay. Can I convert this into bytes? Man. Oh, but this is an error here. I need to add something here. The lim. Wait, what restring? Where do I put this restring? Ah, till the end of the line. So there you go. Then we do text bytes, or can I do? I shouldn't block them. Okay. Writes the line to UDP connection. The separate channel run. Okay, whatever. That's not. We're not ready yet. Writes the line to UDP connection using this. Okay. My problem is how do I write? Should I iterate? I need to do this because we do for b range txt con dot write b. We have that. How do I get bytes then? Write the line to the UV connection using con dot write. I need to send it bytes. String to bytes. Let's do that. String to string. Beautiful. Okay, so then, con dot write text. There you go. What is this? No format directives. Okay, that's true. Alright, you have it now. Okay. Alright. We have this infinite while loop. Up, up, up. Okay, also I probably shouldn't do print ln. I should just do print. Alright, go. Okay, let's run this to the got a connection going. Go run this basically, but UDP-less sender. Panic! Oh my god! Invalid memory address or no or a dereference. Okay, that sucks. Main.go. What am I doing that though? Go, okay, wait. Go run cd TCP. Oh no, not TCP. Go run UDP. UDP sender. Okay, go runtime error. Invalid memory address or okay, it's probably this thing here. Happy now? Oh, there you go. So hello. Wait, we got this going on here, right? So cool, bruh. That's sick. All right, I think that works. What's true of UDP? It guarantees packet writing that says percent. Handshake confirms this. Let's see how they did it. Bum ba da bum 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 ba bum bum. All right, so yep, yep, yep. Oh shoot. Oh okay. Stupid. Local host this 4269. UDP address. Yeah. That's super cool. All right. Anyways, thanks for watching, guys. I'll see you guys tomorrow. Peace.